Quantum mechanics. It sounds so complex, doesn't it? But what really is it? According to the Merriam-Webster's dictionary, this is the definition. But that doesn't really make much sense. So allow me to break it down for you. In theory, quantum mechanics is the study of extremely small subatomic particles, and some examples include protons, electrons, neutrons, quark matter, and many other things. But the core concept behind it is something known as the wave-particle duality theory. Objects in the quantum field are either classified as waves or as particles, and have distinctive properties as a result. However, the theory explains that sometimes particles can express properties of waves, and vice versa, waves can express properties of particles. Now, let me show you an example of this. Scratch that. One of the most famous experiments in physics is the Young double-slit experiment, which is where a coherent light beam was passed through two slits that were close to each other. As you can see, the light creates waves, and there are specific spots where the light is either brighter or darker. And the brighter spots are indicated by the large white circles, and the darker spots are indicated by the black lines between the circles. Now this makes sense as light is a wave, and it became a wave after being passed through the slits. But what would happen if instead of shining light, we passed small particles, say electrons, through the same slits? Well, the exact same activity is observed. However, instead of the brighter or darker spots, there are simply higher or lower concentration of electrons in certain areas, again illustrated by the large black circles or the white lines between the circles. Now, this is an example of a particle sharing the properties of waves. Now, let's prove the reverse as well, shall we? Let's picture an atom. Here is the electrons revolving around the nucleus. And suddenly, one of these electrons drops down to a lower energy level. And as a result of this, it produces what is known as an emission. This emission is in the form of a photon. And when we consider the light is actually made up of these packets of energy or photons, in reality, these packets of energy are really just particles of light. And this is an example of a wave expressing the properties of a particle. My name is Krishnanshu Gupta, and I hope you learned something about quantum mechanics from this video.